Short packets transmission modeling in unmanned aerial vehicle systems. Kharchenko, Grekhov, Kondratiuk. Communication links in unmanned aerial vehicles network are presented on this slide. Here we can see satellite relay, GNSS channel, ground control station, mobile ground station, unmanned aerial vehicles links, satellite links. Ultra-reliable and low-latency transmission will be a key feature for the next generation of wireless communications and will be based on the transmission of short packets. The aim of this report is to build model of ground control station, satellite, unmanned aerial vehicle channel using MATLAB Simulink software, and to obtain dependencies of the bit error rate on data rate, ground station antenna diameter, and satellite amplifier nonlinearity. Relevance of the topic. The topic was chosen because in the existing literature there is no quantitative information about data traffic in ground control station, satellite unmanned aerial vehicle channel. In general, there is no theoretical studies developing methods for predictive analysis of satellite unmanned aerial vehicle relay behavior. Our model for mobile communication is shown on this slide. Ground control station is connected with aerial relay drone, which is connected with unmanned aerial vehicle. Here you can see average utilization of links and latency. Model characteristics are given in this table. The first column consists of structure elements, the second column bandwidth in megabits per second, and the third column distance in kilometers. Aerial relay drone is located at the distance 50 kilometers from ground control station and from unmanned aerial vehicle. Impact of packet size on end-to-end message latency are given on this slide. Dependencies of latency in milliseconds on transaction size in bits are given here. Three different values of bit error rate were chosen: 0, 1.1, 0.1% and bit error rate 0.2%. Figure demonstrates the dependence of the latency on the transaction size parameter and the role of bit errors in the aerial relay drone unmanned aerial vehicle channel. From the data, it is clear that the latency is a nonlinear function of the message size. In the absence of bit errors, the latency is practically the same for all considered packet sizes. The appearance of bit errors in the aerial relay drone unmanned aerial vehicle channel dramatically increases the latency at transaction size more than 100 bits. Impact of packet size on latency for different data rates was analyzed. Dependencies of latency on transaction size are given on this slide for two different data rates. Message delivery delay is a critical parameter. Figure shows the latency dependencies on the packet sizes for different data rates. T1, it's 1.5 megabits per second. T3, 44.7 megabits per second. For transaction sizes less than 100 bits, the latency changes slightly for both data rates and increases with packet size. Latency in message delivery is determined not only by the data transfer rate, but also by the size of transactions. From the data in figure, it follows that for small packets the latency is approximately the same. Impact of packet size on throughput is shown on this slide for three different values of bit error rates. Figure shows the dependencies of the throughput on the wireless link when exchanging data between ground control station and unmanned aerial vehicle on the transaction size for various bit error rates. Increasing the transaction size results in a significant increase in throughput for transaction size more than 300 bits and virtually zero for transaction size between 10 bits and 100 bits. Increasing the bit error rate from 0% to 0.1% results in a 5 increase in throughput for transaction size 1000 bits. This circumstance plays a significant role in the transmission of intelligence content. Result summary. Channel model was built to simulate data exchange using NetCracker software. Short packets transmission for unmanned aerial vehicle via a mobile drone was first simulated. Short packets latency and throughput were evaluated for different transaction sizes and data rates. Results are of practical interest since they allow us to predict the channel performance under critical conditions. Thank you for attention.